My name is Pete Johnson. I'm the field CTO of AI at MongoDB. And in this video, we're going to do some vibe coding. Specifically, I'm going to show you the setup that I've been using for vibe coding the last couple of months, which involves Claude Code. And then we're going to use that setup to build a mean stack application on top of a default sample database that you can get as part of any Mongo Atlas free forever tier. So why do this at all? You may have seen the recent 2025 Stack Overflow developer survey, and it had a lot of AI questions on it. Of all the AI questions, the vibe coding one is the one that really stuck out to me. When asked in your own words, is vibe coding part of your professional development work? A whopping 72.2% said no, and another 5.3% said no emphatically. To get that many developers to agree on anything is rare in this survey, let alone this emphatically. And if you look closely, the number of people who even responded to this question was only at 54%. So I suspect that not a lot of people are doing vibe coding, and that's perfectly understandable. There's been a lot of things in the media about it potentially taking jobs and so forth. So I wanted to use this session to show you what vibe coding is good at, what it's not good at, and to show you that it still needs some help. It needs a professional developer to get the most benefit out of it. Here's a diagram of the setup we're going to be using. On the far right, we're going to be using that mflix sample database that comes with any free forever account that you can put on MongoDB Atlas. And specifically, there's a movies collection in that mflix database that we're going to be creating a mean stack application to allow you to browse the 21,000 movies that are in that collection. On the far left, we're going to be using Claude Code to create that mean stack application. We're going to use that in a terminal window inside of VS Code. We're going to do it that way so that you can see all the different files that Claude Code is creating along the way. In a couple of moments, I'll be going through the core system prompt we'll be using for Claude Code, the list of commands that we're going to allow Claude Code to use, like in our bash. And we'll go through the different sub-agent props. We'll have 3 of those. To glue the two environments together, we're going to be using the MongoDB MCP server. If you've not used the Model Context Protocol yet, this is a protocol that our friends at Anthropic announced last November. And you can think of it as a facade on top of your favorite API, in this case, the MongoDB API. It exposes methods that are part of an API into something called a tool or a set of tools. And think of that as a way that an LLM can understand what an API does, the circumstances under which you might call that API, and the data, typically in JSON, that each of the tools accepts as input and will return as output. Now, a couple of ground rules for this video. I'm not going to be doing any manual coding. I am going to babysit the agents to make sure that they don't do anything catastrophic. And we will likely need to provide iterative corrections. This won't work in one shot. We're going to have to iterate over it a couple of times. And that's where having some expertise in software engineering is going to help us out. And specifically me, while I did write my first line of code as a 6th grader in 1981, and I've done some Node before, it's been a while, and I've never written my own full mean stack application on myself manually. I have gone through this exercise a couple of times in preparation for this session, so I kind of know what to look out for here. Let's take a closer look at this setup now. So I've got the slide here on the right-hand side, and on the left-hand side, I've got some browser tabs that show some of the details that we're going to be using here today. First, let's look at that Atlas database. So you can see here, I get a number of different sample data sets. When I set up that free forever account on MongoDB Atlas, we're going to be using the sample mflix database and specifically the movies collection. As you might imagine, that movies collection has, like I said before, a little over 21,000 documents in it. And each document has this same basic schema to it, where each film in that movies collection has things like the genres, the runtime, the cast, a link to the poster, all the kinds of things that you would think a movie would have. So that's this far right here. Next, let's look at the MongoDB MCP server, which you can find out on GitHub. I've downloaded that and installed it locally. You can follow the getting started, look at the prerequisites and the setup yourself. I'm going to show you how we connected it to Claude Code here in a moment. The thing I want to highlight during this setup is these are the different tools that the MongoDB MCP server exposes. And if you've used any of the drivers for MongoDB, some of these terms are going to be familiar to you. So there's connect. So how do you connect it to your database instance? Find, how do you run a query? Aggregate, count, insert one, insert many, so forth and so on. These are the kinds of things that you would need in order to interact with a MongoDB instance in one way or another. And finally, at this sort of medium level of setup, we're using Claude Code. And really that runs on a variety of different operating systems. You typically use it at the terminal window like we're going to use. It's in any place that you can run Node.js. It's a pretty simple npm install. So that's the high level of our setup. Let's get a little bit more detailed by looking at the code here. So first off, we're looking at my local VS Code. And ordinarily you wouldn't show someone your connection string, but the configuration of the MCP server into Claude Code can be tricky. I wanted to show you this syntax. And when we're done with this recording, I'm going to remove the user that's associated with this connection string to keep my own security safe. But anytime you want to add an MCP server to Claude Code, it's this Claude MCP add, and then the name of the MCP server, 2 dashes, some information about how you launch it. And the MongoDB MCP server gets launched with npx. Any MCP server has 2 modes that you can use. There's a local mode where the MCP server will connect to its client and exchange information over standard IO, or there's a remote mode where you can use HTTP. I'm going to use local here, and I recommend that for most MCP server usage at this point. And then the MongoDB MCP server needs a connection string. So how does it know to connect? What's the information it needs to connect to this specific instance? Like I said, you ordinarily wouldn't show this in plain text like I am here, but I wanted to show you what the configuration looks like. I'm going to remove this user later. I've got the same connection string in a .env so that later we're going to use the MCP server to build our application, but we're not going to use it within the application. Instead, we're going to use standard methods, and we're going to pull this environment variable for those purposes. I've gone ahead and I've already configured the MCP server with my local Claude Code installation. And you can see here that I passed it a pretty simple prompt. Use the MCP server to connect with MongoDB Atlas in the sample mflix database. Tell me about the collections. And you can see that the main, what I like to think of as the orchestrating agent, does that. It flashes a date here, and you'll see why it does that here in a moment. It uses one of those tools in the MCP server, specifically list collections. So it gets the list of collections within that sample data set. And if we check this, it's the same names of collections that we can see in the Atlas UI. It then gets information about each of the schemas and uses one of the other MCP tools to get counts, and then reports back on all the information that can find about those collections. So that's just Claude Code interacting directly with that MCP server. Before we actually do our prompt, let's look at some of the details of how we're going to use Claude Code. At the root of any folder, you can establish some sort of standing instructions for what I like to think of as the orchestrating agent. In this case, we're putting that in our Claude.md, and it's any markdown that I want to put in here. And specifically, I'm going to tell the orchestrator that it's a team leader, and I want it to use each of the sub-agents to the best of their abilities. I identify those sub-agents for the orchestrator. There's a front-end engineer named mean stack front-end and what it should be doing, and the back-end engineer and what it should be doing. For each prompt it's given, use the command line to get timestamps, and that's why we saw that timestamp in the example we just saw a minute ago, because I want to mark the beginning and ending of different tasks that I give it and see how long each one takes. I tell it, and it doesn't always do a great job of following this, don't show any connection strings or any API keys. But I tell it after you complete a prompt, make sure you update the documentation with our third sub-agent, the technical docs writer, that might be impacted by the changes, summarize all the work, Ignore unit testing for now, and that's to keep this demo a little bit tighter, but do some basic functionality testing to make sure the front end and the back end can talk to each other. And then I've also got it to anytime it completes a set of tasks to make sure to do a git add. I did do a git init in this folder so I can track the changes over time. And I found that it's important to do that because in case any of the agents do something you don't want it to, it helps you back out to the last known good a little bit easier, and it's going to track all the commit messages for me. So that's the orchestrating agent. If you look in my .claude folder, there's an agents folder, and I've got 3 different markdowns that then define what each of the sub agents is going to be responsible for. Now, this is a Claude code format. That's an offshoot of Markdown. You can see each of these guys is given a name, a description that for the orchestrating agent, what are the circumstances under which you should call this sub agent? And then there's some instructions for each of the sub agents. And this one, because it's the back end, you might imagine that this is using a lot of back end terminology and Express. For the front end, you get a similar set of instructions, but this time with Angular because we're doing mean stack. And then the technical writer, we wanted to do some code analysis, some documentation generation with some documentation structure and so forth. So we've got 4 different agents. The orchestrating agent is defined in the Claude.md. The individual sub-agents are defined here in the .claude agent subfolder. And you can either drop those files in yourself, or if we go to the command line, you can see if I do a / first, that gets me access to some of the more administrative commands within Claude Code. And I could look and you can see each of the 3 sub-agents is available, and each one of them is going to use Sonnet as its main LLM as opposed to Opus. Now, I should mention that I'm on the Claude Code Pro plan, so I'm not going to be as concerned about token usage here, but your mileage may vary depending upon how you're trying to consume the LLM. Last thing I want to show you before we actually do a prompt and get some work done, there's another file in here that you can put settings.local.json. And this is where you give the different agents permissions for what tools should they be able to execute. Like I said, I did this as an exercise a couple of times before this formal recording. So you can see that I've already given it permission to run some of the MCP tools, but I've also given it some permission to run some local commands in my bash shell as well. If you don't do this, every time it goes to execute a tool, it will likely ask you, do you want to give permission? If you say, you have the option of saying yes, no, or yes throughout this entire session. If you do say yes throughout the entire session, it will add it to this block. So all I've done is I've shortcut that so that you don't have to watch me say yes a bunch of times, and added all these different bash shell commands and the MCP server commands to the allow list. So that's the setup. Let's do some actual work here. So I've already got a prompt that I'm going to copy and paste into Claude Code. And what's going to happen here is the orchestrating agent will read this, will come up with a plan, and then start to delegate tasks to the different sub-agents. And specifically, I'm going to ask it to use the MCP server to take a look at the database and the specific collection that we want to create our application off of. I'm asking it to build a well-formed mean stack application that for now just has 3 pages. The root page is the home page, and it'll have a list of alphabet letters. When a user clicks on one of those letters, it'll take them to a second page, which then shows them a subset of the movies that begin with that letter in some well-organized cards that display 15 movies at a time. And if it doesn't do it automatically, we can add some paging later. When a user clicks on one of those cards, it takes them to the third page, which shows all of the information associated with that specific movie, and make it all pleasant to work with under a color scheme that's similar to MongoDB.com. The code should be well organized with front end and back end code in different folders. When having the code connect to Atlas, use the connection string in the root.env file. So pretty simple set of commands. I'm going to pop this into Claude Code. I'm going to copy that and paste it. And then I'm going to make this window a little bit bigger. So it gives us that starting time. So 10:24:15 Eastern time on Wednesday, August 20th is when we started this. And what should happen next is we've got updated list of to-dos, this is the orchestrating agent coming up with a plan. These are all the list of things it's going to do. Examine the collection, set up the Angular backend, set up the Express backend, and so forth and so on. You can see it's there using the MongoDB find tool to take a look at what comes back. It did a limit of 2 with that initial find, so it can see 2 movies to get an idea of what the schema is like. Now it's going to have the team work on the front end and the back end in parallel. And what we should see next is, here's our back end. It's going to build it based on Express. Notice that color scheme in blue is exactly what we saw in the markdown here. So the back end is in blue, the front end is in green. And what we'll start to see is each of the sub agents will come up with their own sub list of things to do, and it will begin to start to work through each of them. And you can see this is an example of what I'm talking about, where it will ask me for commands. Typically, anytime it's going to create either a new bash shell or a set of new files for the first time, it'll ask you explicitly if you want to let it do that. I'm going to say yes, and don't ask again for this session. We can see an example on the upper right of the kind of file it's going to write, and we're going to let it do that for the rest of the session. So notice that for the mean stack backend, we've got this blinking light here, and we've got it for the front end as well, that these guys are working in parallel. You can see underneath each, it discusses how many more tool uses it's already got in its plan. And we'll see a little bit later when it's done, it'll not only show the aggregate number of tools that it used, but also the tokens it used and how long it took each individual step. So we're back a few moments later, and you can see that the backend has gotten to the point where it wants to start to test its backend server. I'm going to allow it to do that and say yes for the entire session. And one of the things you might have thought of, can the front end and the back end really work in parallel? Because if the front end doesn't have the back end to call and doesn't know what the return structure is like, can it really complete its work? And that's the right thing to ask. And you're 100% correct that it can't complete its work. What almost always happens when I run this exercise is that the first time through, some of the specifics of the data exchange between the front end and the back end don't quite work yet, and it needs some guidance on how to fix it. Now, the other thing to notice here is within Cloud Code, it can actually run backend processes for you. So you might have noticed that the backend subagent has started the backend service, and notice down here it says one bash running. So it's actually running and keeping track of that process in the backend. You can see here as it's going through its testing, it's going to try a curl command against an endpoint to try to get the list of alphabetical letters. And we can see here that that was successful. And now it's going to do this a page at a time for some of the others, for some of those other endpoints. There you can see it doing it for an individual movie. And now it even implemented a search, even though I didn't tell it to. If the past runs of this are any indication, the backend will complete first. The front end will take a couple of minutes more. And the back end is now done. So you can see the back end used a set of 45 different tool uses. So sometimes that was calls to the MCP server. Sometimes it was writing to files. Other times it was doing things like git commit or making curl commands to the different endpoints. In some, it used 43.3K tokens, and it took it a little under 6 minutes overall. The front end will take a little bit longer still. We're back after a little while, and we can see that the front end just finished. It took 63 tool uses, far more tokens than the back end did. It took about 10 minutes and 21 seconds to complete. As we asked it to in the initial prompt, the orchestrating agent is now going to do some testing of the front end and the back end connectivity. While it's doing that, let's look just a little bit at some of the code that got generated. Now, like I said, I'm not a big mean stack guy, but I know enough from other kinds of frameworks about the idea of routes for the backend. So if we look at our movie routes.js here within our backend, we can see that it's got 4 different routes established. One for that first page to return the list of alphabet letters, the second one for search, which is additional functionality we didn't ask it to do, but we'll see if that actually works. For the second page, if we're doing it by letter, it'll return a paginated movie starting with a specific letter, and then for an individual movie with an ID. We then go to, I think it's controllers. We can see the code for that alphabet and making the call to the model to get the alphabet list and return that successfully or error handle. Similarly for the letter, similarly for the individual movie ID. While we've been looking at our generated backend code, we can see that the orchestration, the tests completed, it committed some changes, and now our technical writer is starting to look at all the code that got generated and now is trying to update some documentation based on that. And typically that means it'll create a README file in the root of our folder. Now, I'll admit the front end I'm not as good at. Angular has eluded me. It's got all these different configurations and package definitions. It handled all this stuff for me. If we look at the individual index, it's pretty simple. The main.ts, the routes. So as we're going to see here in a moment when it's done, if the previous runs are any indication, it'll get probably 80% of this right. Something won't work correctly, and we'll have to tell it what it is that didn't work correctly. It'll iterate for us and start to fix things. Usually there's a little bit of tweak we need to make to each individual page. But when the doc writer finishes up, we'll see how that pans out. And here we go, it's complete. So we can see the technical writer only used 17 tools, only took a minute and a half, 30,000 tokens. In total, it took us about 14 minutes to execute all of that. And we've got some instructions here for how we can interact with the front end and the back end. And it put all this stuff inside a Git for us. Now I'm going to ask it to go ahead and start the bashes for me. Let's take a look at what this looks like. Now, this is what I was talking about. So we do have a home page and it does come back, but we get an error message, invalid movie ID format. So I'm going to tell the system that we get this. Now, it claimed that it had already done some system testing, some integration testing, and that it worked. But we see visually from a human perspective that it actually didn't. And this is why vibe coding isn't going to completely take over the industry at this point, is there's some things the models are really good at. It generated a ton of code for us, even for somebody like myself that is not super familiar with this particular platform. But it can't do everything. It still needs a human in the loop to give it a little bit of guidance. So it missed an error. I just told it about the error, and now it's going through and correcting it for me. So let's see what we get now. If I load this, we're close. So I've described what I'm seeing now. That I've got a grid now, but there's no letters in any of the items in the grid, and when I click on them, nothing happens. So now it's going to try to make sure that the back end is working correctly, which I have a feeling it is. It's almost always the front end. And like I said before, one of the side effects of having the front end and the back end being constructed at the same time is it's harder for the front end to understand what the exact data format of the back end is going to be when the back end hasn't been written yet. So you can see here, the back end is returning an array of strings, but the front end expects an array of objects. So that's what I mean, is there's this sort of disagreement between the front end and the back end, and that's a consequence of doing them in parallel. So it takes this set of iterations to sort of adjudicate those two things. And it found another error when it was doing its own testing. Going to kill and restart the back end for us. We'll let it do that curl command. And notice that this is the orchestrating agent doing most of the heavy lifting at this point. Now it claims it's fixed, but let's refresh this. And there we go. So not only do we get the letters as expected, but it also, this is kind of a nice feature that I wouldn't have thought of. It gives us a count for how many movies are in each letter. If I click on this one, and we see we got a similar issue here. So now if I tell it, and we'll likely go through a similar set of, hey, the front end and the back end aren't talking together. We can also see that there's an error here with this back navigation. The navigation actually works. The UI of it doesn't work great. We'll let that pass for now for the sake of time. And we'll go through this exercise again. So again, it's not that it's perfect, but I think you'd agree that I get to a workable solution far more quickly than if I had done this manually. Now, you might argue that this is a little bit of a contrived example, and you'd be right. I mean, we already have a data set, which is unusual, and we're using a well-established pattern, namely the mean stack. So if you're doing something novel or something super specific that isn't out there in the public domain, with a pattern that isn't being used, this isn't going to help you as much. So I happened to choose an example that was with a well-known stack, a well-established pattern, and some existing data. So your mileage is going to vary here a little bit. Still getting some errors here. Yes, pagination data is missing. And again, we have a misaligned model that we're passing back and forth between the back end and the front end. So just like we saw with the root page, it's going to do it for the second page, and it'll fix that so that these two can talk together correctly. You might also wonder, I keep using like please and thank you. That's probably not necessary, but I don't know, it somehow seems wrong not to. We'll do this new curl test. It looks like that works. Let's refresh this page, and it does work. So now, this first movie here doesn't have a poster image associated with it, but the others do. And if I click on A Beautiful Mind, actually the last page actually works. Or if I pick on this, there's a couple of UI things that we could ask it to fix. But you can see that we get far more information here when we click through to the third page than we got on the second page. And even though the UI is a little clunky, that we don't have, nice arrows here that we could go in and fix, the basic UI for us to navigate this works correctly. On the second page, we could probably use, let's see if there's some pagination here on the bottom. It would be nice to have that replicated at the top. But, here we've gone, let's see, we started at 10:24. It's now 10:48. So in about 24, 25 minutes, we went from 0 to, not the most beautiful application in the world, but some basic navigation of this content that has 21,000 movies in it. So let's recap what we just saw in this video. We examined a vibe coding setup that was rooted in Claude code. We used VS Code to observe it, but really we were using a terminal interface of Claude code within VS Code, and we did that so that we could see changes to the files as it was going. We had some data in the MongoDB Atlas sample data set, and we used the MongoDB MCP server to sort of glue those two together. We gave this system an initial prompt that gave it some specific instructions to go set up a mean stack application for us. And what we saw was that while it generated the basic guts, the basic skeleton of that application with that initial prompt, we had to give it some subsequent debugging prompts because it got some things wrong. So I don't think we're to a point where vibe coding is going to take away everybody's jobs. It still needs some human intervention and some human expertise to sort of guide it. But we did yield a working mean stack application in about 24 minutes. Thanks so much for watching. Hopefully that takes some of the fear out of what vibe coding is and what it is you can do with it.